Welcome everybody. In my last video, I showed you how to realize bidirectional communication between a phone and the ESP32. But the data we sent back and forth were just simple bytes. So as long as you just want to communicate with 256 values, you're good to go. But typically your application will require larger variables and maybe even more complex structures. So how can you now transmit values larger than 256 in a reliable manner over Bluetooth or serial that is based on bytes? So before we dive in, what is a byte? I think most of you will know. A byte consists of 8 bits. So for example, here 01011001. So that's 1 byte, and in decimal values this represents 256 values, so from 0 to 255. And the way that now serial communication or even Bluetooth functions is that individual bytes are sent from transmitter to receiver. The receiver then has a certain receiving frequency and might receive 2 bytes at the same time, might receive just a single byte, and you need to make sure that the processing is done accordingly. What's the challenge in transporting larger values? Here are a few examples. If you just have 45, that is a single byte. For 486, you will need 2 bytes. If you go to 234,000, you'll need 3 bytes to encode it. And with 524 million, you need 4 bytes. So let's say your receiver now receives 4 bytes. There could be lots of different ways how to decode this. It could be one large 4-byte number, but it could also be a 3-byte number followed by a 1-byte number. Or it could be 2-byte numbers. And so you need some sort of rules on how you'll decode it, otherwise you'll do it wrong. So the solution that we're going to use together in the implementation is that we're going to always use the same amount of bytes for certain numbers. And that way, if you know what kind of number you're receiving, you know how many bytes it should be. But there's different kinds of numbers we want to transmit. Typically, there's not just only one knob or one sensor out in the field from which you're gathering data. You will have multiple sensors, or you'll have multiple knobs, sliders, whatever. And whenever you send a value across, like slider value 40, you want to know, so which slider was that? And a good way to do that is to give your controls ID numbers. And so each control has an ID number and a value. In this example, I showed 2 switches. Switch number 1 is ID 1 and the value is 0. It's switched off. The second switch is ID 2 and the value is 1. And so in part 1 and 2 on Bluetooth communication, I combined the ID and the value in 1 byte. And that's why no synchronization was needed. Whatever byte you received, you have all the information, you have the ID and the actual value, so you don't have to join them together. That becomes a little harder if you have sliders, for instance. With sliders, there's many more values to transmit across because a slider can be, in this case, 0 up to 80, but you have sliders where you maybe want to go up to 1,000. And then the slider value itself already requires the use of multiple bytes. Now there's of course many ways how to do this, but the simple implementation we'll do today is that we'll have a structure where the first byte we're going to send over is the ID byte, and then the second and third byte is going to be the actual value, the actual data value. The one thing though is that maybe there's a bad communication channel and synchronization is lost. Then the receiver needs to always be able to resynchronize. Now, there's very many ways to do this resynchronization. If you send out lots and lots of data, you might want to just have a start bit and a stop bit, like MIDI sysex, for instance, uses. But in our case, we're going to differentiate between the ID byte and the actual data bytes by just using different numbers. So we'll use within the byte only values 128 to 255 for the ID byte. So basically ID 0 is going to be 128. And then there can be 128 ID values. In the second and third bytes, we'll only use the values 0 to 127. And so as we have 2 bytes, though, we can combine them together and thereby get up to 16,384 data values, which I think is enough for most of your projects. So let's get started and implement this communication channel between your phone and the ESP32. As a basis, I'll use the code from part 2, and then you can code along if you want. If you just want the result, there will also be a second download link to GitHub where you can just download the final result and start using it. So here's GitHub, and we'll briefly download the code as usual. All right, then I'll go and unzip this. And let's start with MIT Inventor. So here we are in MIT App Inventor, and we now load the project by going to Projects, Import Project, choose File, and then in your download folder, select the app you downloaded, and then the Bluetooth app part 2.aia. So this was the status as we left it in part 2, where all the communication was done within 1 byte. So let's first change this. And whenever you now press a button, then the ID is sent as a first byte, and then the second and third byte will be the actual value. And for that, we're going to blocks, and we're going now to start a routine, because you don't want to code this over and over again. We want to have this the same, regardless if you have a button, a slider, or whatnot. So we're going to procedures, and we need then the upper one here. And we need a few values, so we need an ID, and we need the first one is going to be ID, and the second one is going to be the actual value. Okay, now that we have the subroutine, we want to first send over the ID. And as we said, the ID is going to have a value between 128 and 255 so that we can recognize it because it's higher than 127. So for that, we're going with math here to just add 128 to this number. And of course, in the Arduino, we then have to subtract 128 again. So the ID is now all set. Now we want to split the actual value into 2 bytes that we want to send over. So how do we do that? Well, I'll just copy paste this thing. And now we go to value. And now we need to do a little bit different arithmetics. The first thing we need to do is figure out what the most significant byte is, and for that basically we can just divide the value by 128 because we're going to use 128 values and then take the floor out of that. So basically we just do floor and then divide by, get value. And I'll just copy paste 128 over. I already wrote that. So this will be the most significant byte. And then the least significant byte is quite straightforward. We just have to do a modulus by 128. So for that, we take this. We don't need floor anymore. Actually, no, that either. This can all go away. And now in math, we just take modulus. Where is it? Here we go. So the modulus of 128 again. And so for debug purposes, we can also write it here in the bottom where I had communication debug info. Whenever something's sent from the phone to ESP32, we can write it over here. So for that, I can just copy paste this particular green block here. I'll put it over here in the bottom. And I want to add here a few things. So I can here on the text go to join and then say, let's say 4 things. Then we can make it simple and say we have an ID, we have a certain value. And so let me just add here on text. So ID. And then value. That way we know what's happening. Whenever we send something, we can verify on the debug section whether or not it's really been sent. All right, now let's move over to these blocks above. We can all change these. So we don't need to write here the bytes ourselves anymore. We wrote a function for that, so this can all go. The only thing we now need to do is figure out if the button is on or off. So we just go here and instead start to use some math. So we start with the button is off. And if then the button is on, oh wait, sorry about that. Then we write 1 into the button value. Otherwise, it will stay off. Well, I guess the last statement's not really needed, but that's okay. And then the only thing we have to do is call our new function. So in procedures now, we see a new call. That's the call of the procedure we just made. I just see that we didn't give it a name. So let's just do that. This thing is going to be called send Bluetooth. Okay. So now let's add the procedure we just made. So that one needs to be here within the initialized local variable button 1, because this is actually the button 1 value. And so we need to do a get button 1 here with value. And the ID we can just manually set. The ID will be 1. So it's super simple now to copy paste this over to the other ones. We need to briefly get rid of these. Copy paste these over. And then copy paste the routines over. Don't forget to change the ID, of course, to, and the button value is going to be updated to button 2 over here and button 3 over here. Okay, so in essence, nothing really changed, but instead of just sending 1 byte, we're sending over 3 bytes. We have first an ID byte, and then we have 2 bytes with the actual value. Now, what's the advantage here? Well, the real advantage is that now we can add, for instance, a slider. And so let me just add a slider straight away. And this slider, if you click on the slider itself on the right-hand side, you can just go with and do fill parent. And that way the slider becomes a bit wider. And here in the blocks, we can now, for the slider, add a routine. So on the left side, there should be a slider here. And whenever the position changes, then we can just straight away call the function send to Bluetooth. The ID, let's make the slider ID 4. We didn't have that yet. And then here we can just go to thumb position. So the thumb position is just the position of the slider itself. Done. So now whenever you change the slider, it's going to send it over Bluetooth, and the value can be up to 16,384. So that should be quite sufficient. In fact, I think the standard slider values are not so high. Maximum 50, minimum 10. So let's just make this 1,000 or something like that, and a minimum value 0, and see if that works. All right. Now you might want to be able to send also time over to the other side. So for that, we can get a time picker that's over here. Let me add that here on the bottom. And then the time picker has quite a few variables on it. So you click here on the time picker with the blocks. And then we need the upper one. After the time is set, that's the function you want to have. Okay, so what do we want to do with the time picker here? We want to be able to send over the time. So we want to combine basically the hours and the minutes. And the best way to do it is just to convert everything to minutes and send that over. So the way that you could do that is we first copy paste here the send Bluetooth command. Now let's make this 5. And Here on the value, we need to do something different. So we want to now add the hours and the minutes. So we'll do math and then do the plus value, once for the hour and one for the minutes. And if you go on the time picker itself, then there will be here somewhere a time picker hours and time picker minutes. Let me briefly see. So here's the minutes. Let me get that on the field straight away. And then hours are over here. And the thing with hours is we want to multiply that with 60 because there's 60 minutes in an hour. Surprise, surprise. Okay, that's over here. And so I'll put the time picker hour over here and then multiply that by 60. And the minutes I'll throw in over here. And that's all you need to do. Now we're done. Basically, you can pick a time, it's converted to minutes, and it's sent over to the ESP32. So this is about the time where we can start with coding on the ESP32 itself. So let's though briefly see whether or not this works. Let me switch on the phone. So here's the screenshot of my phone with the app running. I cannot connect to the ESP32 yet because we didn't program that or reprogram that yet. Let me scroll down so you can see the bottom part of the phone, and then we can test whether the buttons at least work on the phone itself. So here's the button part of the phone, and when I now press a button, then you'll see that indeed in the debug section from the phone to the ESP32, button ID 1 is sent with value number 1, or when I switch it off again, value number 0. If I select the slider, then you see now ID 4 is changed with value number 770 all the way up to value 1000 if I go all the way up. And let's test the time picker. So if I click on the time picker itself and let's take a simple time, so let's say 1 hour and 0 minutes, then it says it is value number 60, which is exactly 1 hour. 60 minutes. Or if I do 1 hour and 30 minutes, then we see it is ID 5 and value number 90. So that all seems to work fine. We can now move on to the Arduino and code everything that's needed there. So for programming the Arduino, we'll go back to the files we downloaded, go into Arduino, and open up the INO file. So here's the Arduino code as we discussed it in part 2. There we delayed always with 1 second before sending the commands back to the phone. Now, just for simplicity, let's remove that delay and mirror everything directly. So let's go through the code, see what we don't need anymore. So we can remove this delay 1 second. Let's also kick out the pins for now. It really is just about receiving the data, interpreting it correctly, and then mirroring it back. Let's kick out all those time stuff. Here's again some pin stuff. Yeah, we really want to just simplify it a little bit. We won't need all this either. So we just receive here the Bluetooth signal and then work with it once received. So this we won't need either. Very, very simple code. Okay, so we start here. Actually, we won't need that either. So, okay, we start with the Bluetooth signal. Whenever a byte is received, we now need to figure out, is this an ID byte or is it actually part of a value? So that starts with if the incoming byte is larger than 127, then we know this is this is an ID byte. So we say, okay, the ID here is going to be incoming minus 128. Remember, we had added 128 to identify it as an ID byte. So we need to subtract it over here again. And let's just define here a global parameter ID. Then we have that settled and we can make it -1 maybe or something like that. Then if it's not larger than 127, then obviously this is going to be one of the value bytes. So we obviously also need a global variable value byte 1, and then value byte 2. Now, if this value byte 1 is equal to -1, is equal obviously with 2 is's in this in C, then what we want to do is then we say that value of byte 1 equals incoming, and else if the value of byte 2 is equal -1, then the value of byte 2 is incoming. So basically, we use the -1 to identify we have not yet received this particular byte. And so whenever the value is then set, then we can see that it's not -1 anymore, and thereby that we need to receive the next byte. So every time we receive the ID and the appropriate values, we need to then reset the global variables again to -1. So make a short function we call reset Rx Bluetooth, for instance, and then in that function we just basically set everything back to -1. So this one, we only really need to call it when we're done receiving everything. So over here we can go and we have all the data we want. So we can now put the value back together and do with it what we want. But then when we're done, basically we say reset Rx BT so that the next byte can be received. Just, I would say for safety, I think it would be a good one as well to reset it right before writing in the ID here, that we know that the value bytes are both also reset here. Might there be a corrupted channel or something like that? And it doesn't hurt to clean it briefly before we start writing in new data over here. So whenever the first byte comes in, it will be identified as ID. The second byte will then be written to value byte 1, and the third byte to value byte 2. But we want to now, when we received all those value byte 1 and value byte 2, we want to put them together again. So we want to have some sort of a value, and that is now, of course, the same as 128 times the value of byte 1. That's the most significant byte, right? Remember that we did that in the phone, plus the value of byte 2. And just for debug purposes, I think it's always good practice to serial print this, and then we can see if it actually is working. ID, serial print ID, and then, yeah, it's a bit clumsy. I think you can do this quicker, but well, this works. And the last one I do print ln so that we go to a new line, and then we can just say here a value. Okay, so this way, whenever it receives something complete, then it prints that, but we don't only want to print it to the debug interface, we want to send it back to the mobile phone. And I could, of course, just send back the ID, then send back byte 1, and send back byte 2. But let's just pretend like we don't have byte 1 and byte 2 anymore. And so how just from the value you now get back to those 2 bytes. So for that, we'll just make another function here. So void send BT, as we had in the, well, we use underscores here. Send. So let's start a function here, void send BT, and we are going to take two integers, the ID and then the actual value we want to send. And of course, we first write, so 128 plus ID. And then we want to write the most significant byte, which is floor. Well, it's exactly the same, right? Value divided by 128. So they're exactly the same as we already implemented, of course, on the mobile phone. And write the value modulus 128 for the least significant byte. And that's all we need to do. So now we can just send back the data by going here and saying send Bluetooth ID, value. So we could now easily process the value, do something else with it, and send it back to the phone. So we can now write it to the ESP32. And let's get back to MIT App Inventor to see if we can now properly detect whatever is sent back by the Arduino. So here we are back with MIT App Inventor. And now basically we need to adjust the receiving block. So in essence, we're going to implement here exactly the same as what we've done on the Arduino. So let's define some variables. We need here global variables, and we'll start with the ID. Then we need a global variable value byte 1, and then we need one value byte 2. And we want to initialize all these three to -1. So this clock periodically runs this function, and it checks now whether there's bytes available from the Bluetooth connection. And when there's bytes available, it processes these. So we can leave this code as is, but the only thing we really need to change is everything inside here. So as long as there's bytes to be received, it will read out the byte and put it into this receive byte local variable. We want to first check whether or not this byte is larger than 127, because then it is a ID byte. So we'll add this over here. And then if the received byte, I'll just steal it here from the stuff we don't need anymore. If the received byte is larger than 127, then we know we have an ID byte, and so we can now set our global variable ID. So with variables, set our global variable ID to whatever we received. But we should not forget actually that we need to, of course, reduce 128 because it's the ID byte. So we'll take minus, and we'll take the received byte, over there, and now subtract 128, not 27, 128. Okay, similar though, we want this reset function to make sure that whenever we have received a new ID byte, that all the other global variables are -1, otherwise the whole function won't work. So we'll add a small little procedure that's going to be the upper one here, that we're going to name reset Rx Bluetooth interface. And this will just simply reset all these variables. So set global ID to -1. And then set value byte 1 to -1 and set value byte 2 to -1. And we want to run this particular function right before we start a new iteration. Okay, all this stuff I don't really need anymore, only this debug line I'll keep. The rest I'll just throw away in the bin. Okay, that just cleans it up a little bit. Good. So whenever we receive an ID byte, we check on that and we write it in global ID. Now let's add some else-if statements here. We need, in fact, two else-if statements. The first else-if statement is that we need to check whether or not the global variable val byte 1, if that is identical to -1. So if we've checked that it's not an ID byte we're receiving, then we are receiving a value byte. And so similar to what we've done into the ESP32, we now check, is this -1? If it is, then we need to receive that particular byte. So we can then set the value byte 1 to our receive byte. Okay, I think that should work like that. And similarly, I can now copy paste this. If value byte 2 is equal to -1, then we can receive this as well. Here, value byte 2 is equal to receive byte. So let's maybe print the value that we've received. So I add here this set debug ESP2 phone text. So that is here in the designer. That is this lower line here in the debug line. So this lower line here in the debug section. And we want to now set that to, well, let's do it similar to what we've done over here. Let me copy paste that, the transmit and receive. Let's see if that's similar, that's the same. So the ID is of course now the global ID, and the actual value that we've received is now a combination of byte 1 and byte 2. So we're going to take math and then take plus. And here we need another math. We need the most significant byte times 128, which is going to be one. And we need to do this times 128. Let me just copy paste this one. Plus the least significant byte. That's it. All right, so let's see if this works. So here's the phone, and let me now connect to the ESP32. And if I now press a button, then it will send it to the ESP32, and the ESP32 will then send it back to the phone. So the one thing we see though is that the value that it returns is 0, and it should have been 1. But I think I found the problem. I wrote here a global variable byte 1, and this should of course be byte 2. And so now if I run it, then you see that the correct value is shown. So let me try the slider. Or the time picker. And as you can see, we can now really transmit very high values without a problem reliably from your phone to the ESP32 and from the ESP32 back to the phone. I realize this is a little bit of a dry topic, building up a communication channel, but once you've done this, you can really leverage on this on many of your projects. So yeah, take the time to get a little bit familiar with how to go from bytes to integers, from integers back to bytes. Let me know if you thought this was insightful. As usual, likes are well appreciated, and I look forward to seeing you in the next video.